Alright, so we're back, and I'm trying to make a connection here between the antiderivative and the area underneath the curve. So we just showed that if I'm going to find the area underneath the curve, I get the change in the position. So, and I also know that the position is the antiderivative of velocity. So we come up with this whole idea about displacement, and S at B minus S at A is displacement. But wasn't this also displacement? From 4 to 9 seconds, the object traveled 50 feet, or it was displaced 50 feet. So when I talk about the fundamental theorem of calculus, it's kind of important. Let f be a continuous function on a closed interval from a to b. Then the integral from a to b of f of x dx is equal to the antiderivative of f at b minus the antiderivative of f at a, where f is, as I said, the antiderivative. Okay, so here's how that related up above. If I had the integral from a to b of v of t dt, that is equal to a step up from velocity, which we said was s at b minus s at a. Exact same thing, just different notation. Okay, I'm just taking the step up function, I'm going to substitute in b, and I'm going to substitute in a. Alright, so our general steps for doing that. Find the antiderivative. Then we're going to find f at b, and it says disregard c. But if you think about it, if at some point I'm going to have f at b and then plus c. And then I'm going to subtract f at a. So I could say f at a, whatever I get, plus c, but it's going to be the same c, so I'm just going to subtract them out. Therefore, I get to disregard it because it's just going to go away because I'm going to subtract the difference. Okay, so I'm going to do this on a separate sheet. Let's look at number 24. And I have the integral from 2 to 5, is it? Yep, of negative 3x plus 4 dx. Now, just for fun, if you wanted to do this geometrically, you could. Remember our rules? This is an easy one that I might just break down. So off to the side, I'm just going to show you. Just watch so we have an answer to build from. So geometrically, and using our rules from 8.5, I would say that's the integral from 2 to 5, negative 3 times x, plus the integral from 2 to 5 of 4. Oops, forgot my d-axis. And then when I find the antiderivative, or if I find the area underneath the curve of those, that's just the line y equals x from 2 to 5. So this would be 2, this would be 5, and the area of that trapezoid would be 1/2 times my base, which was 3, times, well, my height, which was 3, times my bases of 2 and 5. Plus, I would add on to that the area underneath this 4 from 2 to 5, but that's just a rectangle whose area is 3 times 4. So if I multiply all this together, I get, this will be 7. This is going to be easy to do in your head, Mrs. Brodart. Yeah, 9 times 7 is negative 63 halves plus 12, whatever that crazy number is. Negative 63 halves, yes, I'm cheating, plus 12 is negative 19.5, or negative 39 halves. I hope I did that right. If not, I'm not erasing this and coming back. Okay, old way. New way. We're going to go ahead and find the antiderivative of negative 3x plus 4. So new. We're going to use the first fundamental theorem of calculus. Antiderivative of negative 3x plus 4. Remember your rules. We're going to take x and we're going to raise the power 1, so that'll be an x squared. And then I'm going to divide by that out in front. That'll give me negative 3/2 x squared. Plus 4x. And here's some notation for you. We're going to go ahead and evaluate that from 2 to 5. So I'm just going to use a straight vertical line after that and say from 2 to 5. Now I'm going to substitute in a 5. And I'm going to get that quantity. So I have negative 3/2 20 times 25 plus 4 times 5. And I'm going to subtract whatever I get when I substitute in a 2. And yes, this will be non-calculator, but I'm going to cheat a little bit just to make sure I got the right answer. This is negative 75/2 plus 20. And then, how about, this is a 6. 12 divided by 2 is 6, plus 8, that's 14. So my answer is negative 75/2 plus 6. I'm a little nervous, I'll be honest. Negative 75/2 plus 6. Yep, I messed up somewhere. Can you find it for me, please? Oh, foo. Raise that to a power. Got it. That's negative 3/2 plus 4x. We're going to go from 5 to 2. It's negative 3/2 times 25 plus 4 times 5 minus negative 3/2 times 4 plus 8. This is, oh, here it is. I missed the negative sign, didn't I? Okay. Yay. So this is negative 6 plus 8, which is 2, not 14. So this is plus 18. Let's see if that's any better. Negative 75/2 plus 18. Yeah, it is. Of course, it would have been much better had I done it right the first time. Negative 39/2. Two equivalent ways of doing the problem, but now we're going to try to use this first fundamental theorem as often as possible. Okay, now remember, there's a couple times where you just can't find the antiderivative. Case in point, I just said the semicircle and then something like absolute value. You want to go ahead and find that geometrically, but let's go ahead and practice this a couple more times on a problem like 25. Because I'm not sure how to graph something like 25. So I'm going to take the integral from negative 2 to negative 1 of u minus, and I'm going to change that right away to u to the negative 2 du. Let's take the antiderivative of that. So I'm going to start with u, raise the power, divide out in front, minus, raise the power of u to the negative 2, which will give me u to the negative 1, divide by a negative 1 out in front. I'm going to go from negative 2 to negative 1. And double check that. Remember, the easiest way to check an antiderivative is take the derivative. Make sure you're in good shape. And now, again, it'll be non-calculator, so we're going to have to watch all our negative signs. I have 1/2. I'm going to substitute in a negative 1 first. Always f at b minus f at a. So negative 1 squared is 1, plus negative 1 to the negative 1, and I'll just write that, but that's just negative 1, minus, now substitute in a negative 2. So I have 1/2 times negative 2 squared, which is 4, plus negative 2 to the negative 1/2, so let's just call that one negative 1/2. It's a mess, but that's why it's non-calculator, because you can do this. So 1/2 minus 1 minus 2 minus another half. Putting those together, I get a negative 3, and then 1/2 plus another 1/2 is 1, and my answer is negative 2. Let's try number 26. I'm going to take the integral from negative 3 to 3 of v to the 1/3 dv. Now again, I can kind of graph that, so if you want to get an idea, the last one I couldn't, but not to spoil this one or anything, but it's a lazy snake. And that's an odd function. And I'm going from negative 3 to 3. So please think for just a second what my area underneath the curve should be. I'm sorry, the integral from negative 3 to 3, assuming we're talking about signed area. Okay, so if you got that in your head, let's again kind of justify this here. This is a good one for us. I'm going to take the antiderivative of v to the 1/3. Add 1 to 1/3, I get 4/3. Divide that out in front, which is the same as multiplying by the reciprocal, and I'm going to run that from negative 3 to 3. Now we're going to substitute in a 3 first. Always be first. 3/4, 3 to the 4/3 minus 3/4, negative 3 to the 4/3. And now if you just think this one through, no, I have no idea what 3 to the 4/3 is, but I can tell you that when I take the cube root of negative 3 and then I raise it to the 4th power, this negative is now gone. So I'm going to get these two equivalent statements but opposite, and my answer is equal to 0. Now, if for some reason it didn't go to 0 and you needed a way to express your answer, if you leave it like this, guys, it's totally acceptable. Okay? But, I mean, come on, give me 0, because I know you can. All right, and then 27. We have the integral from 3 to 1. Okay, so graphically, think what that's going to do to our 4x dx. So if you recall our little rule here, if I go from b to a of f of x, then that was equal to the opposite of the integral from a to b of f of x dx. Okay, so I just had the negative sign in there. So now watch how this plays out here, because I'm not going to change anything. And they always said you have to do the b first, but technically the b is always just what's on top of the integral. So geometrically, if I were to just think about what this would look like real fast, I again have a trapezoid, but now I'm going from 3 to 1, so I'm going left and up. So my final answer needs to be a negative. So let's see if I get a negative this way just by using the first fundamental theorem. Take the antiderivative. You're going to raise that power, so I'm going to go to an x squared, and I'm going to divide out in front by a 2, so I get 2x squared, and we're going to evaluate that from 3 to 1. Substitute in a 1 first. That's 2 times 1 squared minus 2 times 9. My final answer is 2 minus 18, or negative 16. If I were to just double check that over here, if I substituted in a 1, this would have been a height of 4. This would have been a height of 12. So the area of my trapezoid would have been 1/2 times 2, 4 plus 12. This would have given me 16, but then we had to recall the direction that we had. So the integral would have been negative 16. So yay, it works. If you can think geometrically and you loved Chapter 8, if you want to continue doing Chapter 8, you can. Those of you who are more algebraic in your thinking and analytical, then why don't you go ahead and take the antiderivative. But sometimes you have to take the antiderivative. Okay, I wish there was a way out. There's not. Okay, so let's finish these up. You know what, I'm going to do this in a separate video just in case that one gets too long. So come back and see me for the rest of 9-1.